All right, let's just jump right in. As an engineer, you're trained to build things. It's what you do. But what if your real job, the thing that truly defines your value, isn't just about building, but about orchestrating value? Today, we're going to unpack the one disciplined process that separates a simple builder from a real market-making leader.
So let me ask you a question. Straight up, is the work you do every day just another feature on a spec sheet? Or is it the foundation of a fortune? It's a really important distinction because it forces you to think beyond the code or the CAD file and really consider the massive commercial impact of your work. And this quote, it just nails it. A groundbreaking idea is awesome, but it's literally just the starting line. The real value, both for your company and, frankly, for your career, is forged in the disciplined process of bringing that idea into the real world. That process, well, it's everything. So, how do you get a handle on that process? Well, it turns out there's this single, incredibly powerful lever that engineers can pull. One that has this huge, outsized impact on whether a product sinks or swims. Let's call it the 80% value lever.
Now, look at this number, 70 to 80%. Just let that sink in for a second. What single process could possibly control that much of a product's final outcome? I mean, think about it. What could have more impact in marketing, more than sales, more than even the brilliant idea itself?
Well, the answer is product design and development, or PDD. This is the whole shebang, the rigorous, disciplined journey from a concept to a scalable product. And here's the kicker. Here's how it controls so much. The decisions made super early in PDD about materials, about architecture, about how you're going to manufacture it, they lock in most of a product's lifetime cost before you've even built one. So mastering this process, it isn't just part of the business, it is the business.
Okay, so to really master PDD, you got to understand its philosophy. It's not just some checklist, it's a whole mindset. It's built on 3 foundational pillars that basically transform the chaos of innovation into predictable, repeatable success. Let's break them down.
So here they are, the big 3. Framework over fortune, which is all about having a repeatable system instead of just hoping for a stroke of genius. Then there's cross-functional velocity, which means getting speed through teamwork. And finally, managed risk, which is about making the unpredictable predictable.
First up, framework over fortune. This means we don't just sit around and wait for a lucky lightning strike of inspiration. Nope. Instead, we use a systematic 5-phase process. You can see it here. It takes us all the way from that initial spark of concept development through system and detail design and right into testing and production ramp-up. This structure makes sure success isn't just an accident. It's engineered. It's repeatable.
Now, what's so cool about this is how it shows our second pillar, cross-functional velocity. Great products are born right at the intersection of innovation, design, and development. When these teams are stuck in their own silos, what do you get? Costly mistakes and endless delays. But when they collaborate seamlessly from day one, you accelerate the entire cycle. Why? Because all that diverse expertise catches flaws early and just builds a way better product way faster.
And our third pillar, managed risk, is all about taming uncertainty. Look, the road to market is paved with challenges. A solid PDD process sees them coming. By proactively identifying potential issues, mitigating technical hurdles, and constantly monitoring your progress, you turn these potential disasters, the kind that blow up schedules and budgets, into predictable, manageable variables.
Okay, so we've covered the why, the philosophy behind it all. Now let's get practical and talk about the how. Let's see how this PDD blueprint actually works in the real world to turn a raw idea into something a customer can actually buy and use.
The best way to think about the process is like a funnel. You start out super wide with a ton of different concepts. Then, as you move through each phase, you systematically test, validate, and weed out the weaker ideas. It's a brilliant way to manage risk and make sure you're not dumping massive amounts of time and money into a concept that was flawed from the very beginning.
Okay, now this is huge, especially for anyone coming from a software background. In the software development lifecycle, the cost of making a change is, well, it's pretty low, right? You can iterate and pivot pretty easily. But in PAD for physical products, whoa, the cost of change can literally explode. It grows exponentially. A mistake caught late in the game isn't about rewriting a bit of code. No way. It can mean scrapping millions of dollars in physical tooling. The stakes are just on a completely different planet.
So here's the big takeaway from that. Because the cost of failure is so incredibly high, being absolutely rigorous in those early phases, it's non-negotiable. It has to happen.
Getting the concept and system-level design right isn't just a good idea, it is the only way to prevent the most expensive failures down the line. This is exactly where that 70 to 80% of cost gets locked in, and it's where you, the engineer, create the most value.
And that brings us right back to where we started. See, this isn't just about building better products. It's about building your career. It's about defining your value in the market. This is the new mandate for every single ambitious engineer out there.
When it's all said and done, your worth isn't going to be measured by how well you can do one single task. It's going to be defined by your ability to think across the entire process, to flawlessly integrate the designer's vision of how it works with the manufacturer's reality of how it's made. You have to master both of those things to deliver what the customer actually wants.
So I'll just leave you with this thought. You're not just a builder of things. You are a potential orchestrator of real economic value. So the only question left is, how are you going to step up and start orchestrating?